All right. Adding and subtracting radicals is going to be very similar to combining like terms. So in the warm-up, we said for something to be a like term, it had to have the same variable and same exponent, right? But here we don't have variables and exponents, we have radicals. Okay? So we're just going to make a note. You can add and subtract radicals when the radicals are the same. Okay, you can add or subtract radicals when the radicals are the same. So it's just like combining like terms, the radicals have to be the same. Okay. And just like when we combine like terms, you only add or subtract the coefficients. I think I spelled that wrong, but it's fine. Did I spell it wrong?
Which one? Coefficient?
Yeah.
That's not right.
Okay. I teach numbers, not math, or letters. Okay, so you can add or subtract radicals, and the radicals are the same, but you're only adding and subtracting the coefficients, just like in our warm-up when we combine like terms. Everyone okay with that? Okay, so we're not going to do anything. We're just going to determine if things are the same right now. So if I give you 2 square root of 3 and 5 square root of 3, would you consider those like radicals? Are those the same? The radicals, are they the same? Yeah, right? I have the square root of 3 and the square root of 3. The radicals are the same. Doesn't matter what number's on the outside. Are the radicals the same? So yes, we're going to put like term or like radicals here. Right now we're just going to identify if they're the same before we start adding and subtracting. Okay, because it's the square root of 3 and the square root of 3. Oh, that's 5th grade. What if I give you the square root of 2 and the square root of 5? Are those the same? No. So they're not like radicals. Can't add or subtract those. What number's in front of the square root of 2? A what? A 1. So if they were like, it would be a 1 on the outside, so 1 plus 1 would give us 2, right? Okay, let's throw you this one. What about the square root of 2 and something you haven't really seen yet? You see that little 3? Yep. Can't even see it. It's tiny. It's the cube root of 2. Huh? Yeah. So I have the square root of 2 and the cube root of 2. We don't really talk about cube roots much in IM2, but you're going to see them in IM3. Would you consider these the same?
Yeah.
No. Okay, they're not going to be the same. Here's why. When we break down radicals, we've been looking for pairs, right? Because I say square root a lot, right? So really there's a 2 on the outside here, but we don't have to write that 2. Cube root, if I were to break it down, do you know what you think you'd look for? Groups of 3. What if I gave you the 5th root of something? What would your groups be? 5. Okay, so they have to be exactly the same. Not only is the number the same, but the little number on the outside has to be the same. Okay, so these are going to be not like radicals. Okay, so let's try a couple examples. So first thing you're going to determine is if they're the same. Can I add them together? Do they have the same radical? Right? What's inside the same? The little number is the same? Just like terms, we are just adding and subtracting the coefficients. So what's 5 plus 3? 8. So 8, and we leave the square root of 2 alone. That's it. That's it. It's not that easy?
I feel like it's not really easy.
Okay, so let's do another one.
No, he's saying it's gonna get harder.
Oh.
He's like, it's not gonna end up staying that easy.
Well, I mean, it's going to get much harder.
I see some big numbers.
Like 5,000. Okay, 7 square root of 5 minus the 2 square root of 5. Are they,
Is that a cube root, that example?
yeah.
Okay.
Are those like radicals? Square root of 5 and square root of 5 are the same. So we're just subtracting the coefficients. 7 minus 2, 5. And then we keep the square root of 5. Okay? Can you try one? How about 8 square root of 7 minus the square root of 7 plus 2 square root of 7? So 8 square root of 7 minus the square root of 7 plus 2 square root of 7. So determine if they're like radicals. If they are, add or subtract the coefficients only. When you have an answer, check with your group. Who has an answer for me? Nobody? You guys are just mad at me. Go ahead, Annie. You got 9 square root of 7. Can you tell me how you got 9?
I put an imaginary 1.
Okay, so you put a 1 here.
Yeah, and I just added them all.
Okay, so 8 minus 1 is 7, plus 2 is 9. Did everyone else get that as well? Okay. So let me give you this one. So 3 square root of 2 plus the square root of 8. I want you to talk to your group, and I want you to come up with what you think the answer might be. So we have two options. We can either say they're like radicals or they're not like radicals. Who went automatically to they're not like radicals? This whole group here? That back group back there, not like radicals? Okay, so I look at that, and Ms. Burt just said they have to be the same, right? Those aren't the same. But, don't give me those faces. What do you know about radicals? You can simplify them. So, which one could I theoretically simplify? The square root of 8. Give me two numbers that multiply to 8. 4 and 2. And 4 breaks down to 2 times 2. So I have a pair of 2's and a leftover 2. Which means square root of 8 is really 2 square root of 2. Are those radicals all that different? No, now they're exactly the same. So I can add my coefficients, giving me 5 square root of 2. Okay, so don't forget things that you've already learned. If you know how to simplify a radical, we can still simplify radicals. Okay? How about you try to? Or do you want me to do one more with you? One more with you? Okay. So let's do 5 square root of 3 minus the square root of 12. So we're not going to discount things right away and say they're not like radicals until we decide if we can simplify. Okay. Can I simplify 5 square root of 3? No, 3 breaks down to 3 and 1, so that doesn't do me any good. Can I break down 12?
Yeah.
So 4 and 3 and 2 and 2. So I have a pair of 2's and a leftover 3. Are those like radicals now? Yep. 5 minus 2. 3 square root of 3. You okay with that? Okay, why don't you try to? How about the square root of 2 plus the square root of 18? And the nice thing is if you think you know you have to add or subtract and they're not the same now, you know that they're probably going to be the same in the end. So that kind of helps you check your work. Can I fit this other one? I think we're just going to do that one, and then we're going to look at one other example. So go ahead and do that problem and check with your group when you're done. All right, let's see how we did. Who can help me? Anyone? I'll come to Annie if there's nobody else. Annie's doing all the work for us today. Go ahead, Jaden.
You do the little factor for 6 and 3.
For 18, so I'm going to break down 18 to 6 and 3, okay? And then 6 breaks down to 2 and 3. So what do you get?
3 and 3 radical 2.
Okay, so square root of 18 breaks down to 3 square root of 2. Plus I still have the square root of 2. What number's in front of that square root of 2? Oh, 1. 1 plus 3 gives me 4 square root of 2. Did we get that? Okay. Last type of problem. There's an X. Okay. What's the rule when you're simplifying radicals? When you're adding and subtracting them? You only do the coefficient if what's inside the radical is the same. Doesn't matter what's inside, it just has to be the same. Are square root of 3x and square root of 3x the same thing? Okay, so I can add or subtract what's out front. 5 minus 2 is 3. Okay, we're going to do another one. So if I give you 2 square root of 3a to the third. Okay, calm down. Plus 5a square root of 3a. We're going to do it together. Right now, is what's in the radical the same? No. So I can't do anything yet. But I'm going to look at what's inside the radical because I know how to simplify radicals. Can I simplify either one of these? Which one? The first one, right? So 3 breaks down to 3 and 1. I can't do anything there, but I have 3 A's. Do I have a pair of A's? So I have 1 pair and 1 left over. Where does the pair go? Outside. So it's really 2A square root of, I still have this 3, don't forget that 3, 3A, plus 5A square root of 3A. Are you okay with that? Are my radicals the same? Okay, here's what you have to be very cautious of. It's like combining like terms, right? So these have to also be like terms. I was able to add and subtract all of these because they were just constants or coefficients. These both have a's. Are they like terms? Same variable, same exponent? So I can add them together. 2 plus 5 is 7. You keep your a. Square root of 3a. What if this one was 2a squared and this was 5a? Could I combine those? No. So you have to remember all the rules of like terms. Okay, everything has to be like terms. You're going to do 2 problems and then we are done with notes. So take a couple minutes and do those 2. Okay, number 9. Are my radicals exactly the same? Yeah, 7y and 7y, right? So I'm just going to add what's out front. So 5 square root of 7y. Are my radicals exactly the same in number 10? No. So let's break some things down. Can I simplify 20? Yes? To 4 and 5 and then 2 and 2. And I also have 2 a's, which gives me a pair. So what's that new radical going to be? 2a square root of 5. Okay, so if they're not the same, you need to go automatically to trying to simplify that radical. Can I break down 45 to 9 and 5? And then 3 and 3? So I have this 3 that comes out. What's already on the outside? An a, so it's going to stay there. And then on the inside, I have the square root of 5. Are they now exactly the same? Okay, 2a minus 3a? Negative 1a or negative a square root of 5. How'd you do? Is it super difficult? Okay.